Good evening, ma'am. Good evening, classmate. I am Maaghop.
And I am Nicole inside.
And today we are going to tackle our topic all about simple reactions of organic compound.
So without further ado, let's get into it.
So first, we have combustion reaction. Combustion reaction is the most common reactions of organic compound and is also known as burning. Combustion reaction is an exothermic process wherein oxygen reacts with a hydrocarbon. The end product of a complete combustion of hydrocarbons such as methane always produces carbon dioxide and water. An incomplete combustion will result in a carbon monoxide or carbon. So I'm going to show you the examples of combustion reaction. The first combustion reaction that I'm going to tackle is a combustion of methane. We have steps to follow. Step 1 is write the chemical equation. So we have step 2, balance the reaction. So now we have the final balance equation of combustion of methane. We have 1 mole of methane reacts with 2 mole of oxygen gas, yields with 1 mole of carbon dioxide and 2 mole of water. We also have another example of combustion reaction, which is combustion of ethane. So as what I have said a while ago, that we need to follow the steps in order to get the combustion of ethane. So we have step 1, write the reaction. We have ethane reacts with oxygen gas, yields with carbon dioxide and water. Step 2, balance the reaction. If this happens in balancing the equation, you will end up with fraction and multiply it by 2. The whole reaction. You need to multiply it by 2. So now, we have the final balance equation, which is 2 moles of ethane react with 7 moles of oxygen gas, yields with 4 moles of carbon dioxide and 6 moles of water. So this is the sum up of combustion of ethane.
So along with combustion reaction comes addition reaction. So what is addition reaction and when does it occur? So addition reaction takes place in hydrocarbons with multiple bonds. We are talking about unsaturated hydrocarbons, which are the alkenes and the alkynes, which have the double bond and the triple bond. Components A and B are added to the bonds being broken. Take note that the double or triple bond breaks because it is where the molecule will be attached. It will be added to the molecule. In this visual aid showcases my first example for the addition reaction. Now this is an addition reaction of hydrochloric acid and ethene. So we all know that ethene has a double bond. What happens to this double bond? Now this double bond serves as a magnet for the hydrochloric acid, which then splits up to hydrogen and chlorine atoms. This hydrogen atom will attach to one of the 2 carbons, and the chlorine atom will attach to the other one. Now why? Why this arrangement? Here comes the rule of Markovnikov. Markovnikov's rule will explain this. So his rule states that the hydrogen will go to the carbon that already has more hydrogen atoms. So the hydrogen will go or will attach to the carbon that has more hydrogens attached to it. But for the case of ethene, the carbon atoms already have the same amount of hydrogen, so it does not really matter where we put which. And so the products of the reaction will yield chloroethane. We have here now the final product, which is the CH3CH2Cl. This is the chloroethane. So this is the finalized addition reaction equation for hydrochloric acid and ethene. Herewith is the addition between hydroiodide to ethine. Now, ethane has three triple bonds. So what happens to this? So the H atom bonds to one carbon, while the iodine atom, bonds to another. Why is this? Following again the rule that I mentioned earlier, Markov-Nikov's rule, which states that the hydrogen will go to the carbon that already has more hydrogens. But for the case of ethane, it is also equal now, just like the first case scenario, so it does not really matter the arrangement. So here is the final product for this addition reaction. 1 mole of ethane reacts with 1 mole of hydrogen iodide, yields 1 mole of iodoethene. So that sums up the examples for the addition reactions. Now we have here the third reaction, which is the condensation reaction. So what is a condensation reaction? So according to our PowerPoint, condensation reaction is a reaction between two molecules forming single molecule and a released water molecule as a product. Biological process such as production of protein, amino acids combine during condensation reaction. An amino acid has an amine functional group on one end and a carboxylic acid function on the other end, and these two ends will have two covalent bonds during a condensation reaction. So we have here an example of a condensation reaction. This is a visual diagram of a sample of condensation reaction. So we have two amino acids. Two amino acids react with each other. We have an amino group and a carboxyl group. So what happens in this reaction? So the two amino acids meet. Carboxyl group wants to join with the amino group. So what happens? To connect the two amino acids, a hydroxyl group from the carboxyl group and a hydrogen from the amino group combines together and separates. They form a separate substance, a separate molecule, which in turn results into water. So now that the OH and the H together is removed and they form the water already, the CO and the HN connects directly. Now this is called a peptide bond. So what do we get at the end? The two amino acids are now linked by a peptide bond. We see here in this red color. And you also get a water molecule, which is H2O, as a byproduct. You also get a water molecule, H2O, as a byproduct. Now, why is this important? This is how proteins are made in our bodies. Proteins are long chains of amino acids made up of peptide bonds. So that was it, and I hope you understand clearly what I was about to say.
So last but not the least, we have saponification reaction. Saponification reaction happens through hydrolysis reaction of an ester. This process takes place because of hydrolysis of long-chain esters called fatty acids esters to produce soap molecule, which are salts of fatty acids. So nata diri ethyl esterate. So ethyl esterate is formed of esteric acid and ethanol. Reacts with sodium hydroxide, yields with sodium esterate and ethanol hydroxide. So karon nganong nganong sodium hydroxide man atong gigamit? It is because hard nga soap ang atong gihimo. Hard nga soap, dili man siya soft. Kung soft kani, potassium hydroxide. So diri balik ta diri sa ethyl esterate. So atong i-determine pa ang positive part o ang negative part. So ang atong positive part is ang kanang esteric acid. So mo ni siya kini. Mo ni siya kana. Mo na siya ang atong positive part. Ang atong pong negative part is ang ethanol, which is kini. Kini. Unya, sa other reactants na po, diri sa kanang sodium hydroxide, Ang atong positive part is ang sodium. Yung atong negative part is ang hydroxide. Which is, nganong naa na siya Na diha, it is because kay positive part po siya. So, mo na siyang, nahimo na siyang sodium stearate. So, mo na siyang atong soap. Mo na siyang, mo na siyang soap molecule. So, mo po siya dali. Since kay it is negative part, so, ang kining hydroxide is mabutang ari po sa negative part. So, ano to? So, that's it. So, that's it. I'm beautiful who I am.